Hello friends, welcome back to our channel Adami Education. Last time we learned a lot of things about plane mirrors. Today we are going to continue with the same, and we are also going to study about spherical mirrors today. So let's begin. The first topic is number of images formed by a combination of plane mirrors. So it's a very important topic. Let's understand it. So there are two cases which can occur in this topic. So let's see. If theta is the angle between the mirrors, so let's imagine two mirrors are placed and the angle between them is theta. First of all, before finding out the number of images, we are going to find the value of a variable, that is n. What is n? 360 degree divided by theta. So this n is applicable in both the cases, and accordingly we are going to find out the number of images. If the value of n is odd, okay, in that case there can be another two cases once again. Let's see the first subcase. The number of images is n when the object is placed asymmetrically between the mirrors, and the number of images will be n minus 1 when the object is placed symmetrically. That means, let's imagine we have two mirrors between which the angle is 72 degree. Okay, in the first case the object is placed asymmetrically, that means at one of the corners or somewhere, but in the second case the object is placed symmetrically, that means exactly at the center of the two mirrors. In both the cases the number of images will be different. Before doing that, let's find out the value of n. N is equal to 360 degree divided by theta. So in this case theta is 72 degree. So if I solve it, I am going to get n as 5. Since n is odd, we are going to follow case 1. So the number of images will be n when the object is placed asymmetrically. So in this case the object is placed asymmetrically. That means the number of images will be n, that is 5 images are formed. In the second case, where the object is placed symmetrically, the number of images is n minus 1. That means the number of images will be 5 minus 1, that is 4. This calculation is only applicable when the value of n is odd. Now there can be certain cases when the value of n is coming as a decimal. So we are just going to consider the integer part, not the number after the decimal. Okay. Now coming to the second case, let's see. This is easier because there are no sub cases in this place. If n, that is 360 degree divided by theta, is even, in that case what will happen? The number of images is always n minus 1. So let us take an example. If theta is 60 degree, so what will be the value of n? 360 degree divided by 60 degree. On solving it, you are going to get 6. That means n is even. So the number of images will be 5. I hope it is clear. So only when the value of n is odd, we are going to consider the two sub cases, otherwise not. Now, based on the observation that we have just made, let us find out the number of images when the two mirrors are placed perpendicularly with respect to one another and when they are placed parallel to one another. Let's see. As you can see over here, this is mirror 1 and this is mirror 2. Okay, and they have been placed at an angle of 90 degree with one another. So theta is equal to 90 degree. So in this case, let us find out the value of n. N is equal to 360 degree divided by theta, that is 360 degree divided by 90. We are going to get the value as 4. Since n is even, that means the number of images will be n minus 1. N minus 1 will give you 3. So as you can see, there are 3 images formed. This is one image, this is the other image, and this is the third image. So whenever two mirrors are placed perpendicular to one another, the number of images observed is 3. Now coming to the next case, when the two mirrors are placed parallel to one another, AM is the first mirror and BM1 is the second mirror. Let's see. In this case, theta is equal to 0 degree because the mirrors are placed parallel to one another. So the value of n is 360 degree divided by theta, that is 360 degree divided by 0. We are going to get the value as infinity. Let me write it at the bottom. We are going to get the value as infinity. That means infinite number of images are formed in this case. So infinite doesn't mean that it's actually infinity. Infinity means many uncountable images are formed. As you can see already in the figure itself, we can see 3 images already. So more and more images are formed, but as more images are formed, the images are not very clear, so we are not able to observe them easily. You must have seen such type of mirror placements in jewelry shops, in barber shops, etc. So in jewelry shops, this creates an optical illusion as if the room is very large. Okay, and in a barber shop, it helps us to observe the hairstyle at the back. But in a way, whenever 2 mirrors are placed parallel to one another, infinite images are formed, which basically creates an optical illusion of a larger room. So these are the 2 main cases of combination of mirrors which will form a number of images. I hope this topic is clear. Now we shall directly move to the topic spherical mirrors. So what is a spherical mirror? We have just studied about plane mirrors till now. Spherical mirror is a mirror which is not straight, which is curved. So I guess you have a little bit idea about it already. Let's just go through the basics first. A reflecting surface which is a part of a sphere is called a spherical mirror. So there is a huge sphere from which some parts have been cut out and they have been converted into a mirror. So those curved mirrors are known as spherical mirrors. So basically there are 2 types of spherical mirrors. One is a concave mirror, one is a convex mirror. What is the difference? As you can see in the figure itself, a concave mirror has a cave-like structure as the reflecting surface. This portion is the reflecting surface and it is basically like a cave. So when we hold a spoon, the portion of the spoon through which we are able to lift up the soup or whatever we are eating, that part is the concave surface and that part will be the concave mirror. On the other hand, in case of a convex mirror, the reflecting surface, that means this part, it is bulged. That means the behind of the spoon. Okay, so in a spoon, you can easily observe the difference between a concave and a convex mirror. The portion through which we are lifting up the food item, that is the concave surface, and the other portion, the bulged out portion, that will be the convex surface. Okay, I guess it is clear. So there is a large sphere from which these parts have been cut out and then it has been polished accordingly to convert it into the required type of mirror. Now there are certain terms which are related to spherical mirrors. Let's go through them and we'll finish the lecture for today. Next day we are going to learn about the ray diagrams on the basis of these mirrors. First of all, center of curvature. The center of curvature of a mirror is the center of the sphere of which the mirror is a part. So like I said there is a huge sphere from where the mirrors are cut out in a factory. So that sphere, the center of that particular sphere is the center of curvature of the mirror, because the mirror is a part of that sphere, isn't it? So the center of the mirror or the center of curvature of the mirror is the center of that particular sphere. Next, radius of curvature. Again, the radius of the sphere from which the mirror has been cut out, that radius is also known as the radius of curvature of the mirror. So let's see. The radius of a sphere from which the spherical mirror is a part is called the radius of curvature of the mirror, like I explained. So generally the radius of curvature is represented using capital R. You can also use small r. Okay, now there's a term principal axis. We will come to that later. Now let's see pole. The geometric center of the spherical surface of a mirror is called the pole of the mirror. So let's make a concave mirror over here. So exactly at the center point, let me just exactly at the center point, the center of the mirror, that is also known as the pole of the mirror. It is represented using the letter P. Now what is aperture? The plane surface area of the mirror through which the light rays enter and fall on the mirror is called the aperture. That means this entire curved part, this is known as the aperture of the mirror. So mirrors can be of large aperture. That means the reflecting surface will be very large. That means it is basically a very large mirror. And sometimes the mirrors can also have a very small aperture. Aperture is basically the area over which reflection can occur in a mirror. Now principal axis. There's a straight line which passes through the pole, and also it contains the center of curvature. Okay, so that particular straight line, it is actually an imaginary line. We use it to construct our ray diagram and to form the image. So the straight line which joins the pole of the mirror to the center of curvature, that is known as the principal axis. Principal axis is the point, or is the line where we place the objects in order to form their images. So next day when we study about the formation of ray diagrams, we will understand this topic clearly. There is another point which is known as focal length or focus of a mirror. We will understand that through diagrams next day. I hope you have understood the basics of spherical mirrors. Let's meet again in the next class. Till then, keep studying everyone. Goodbye and have a nice week ahead.